Another law is Avogadro's law, and this relates volume and moles. In all the other examples, we're talking about the amount of gas staying the same. But what if it changes? If we increase the amount of gas, we measure it in moles, if we increase the amount of gas and we keep the temperature constant and the pressure constant, we observe that the volume increases. So as we increase the number of moles, the volume increases. And it is directly proportional. And this relationship was first formally stated by Amedeo Avogadro. He was born the same year that our country was born. It's kind of cool, 1776. And so, sorry, I'm getting out my calculator. Tired of using my cell phone. So volume is proportional to the number of moles of gas. It's amount of gas in moles, not the mass of the gas. And this makes sense because here's a child blowing up a balloon. When you blow up a balloon, you're putting more air, more gas molecules into the balloon, and it causes the balloon to get larger. So we can do problems with this as well. I never really wrote out Avogadro's law for you there. Sorry about that. I don't want to use yellow. It's V1 over N1 equals V2 over N2. So that's Avogadro's law. A 4.8 liter sample of helium gas contains 0.22 moles of helium. How many additional moles of helium gas must be added to the sample to obtain a volume of 6.4 liters? Well, we're going to approach this like we approached the other ones. We're going to look at the numbers, and we're going to make a table. We've got condition 1 and 2. We've got a 4.8 liter sample. And that contains 0.22 moles. And the other number that's given there is 6.4 liters. So we'll put that in here, 6.4 liters. This is volume, and this is N. N for number of moles. And what can we solve using this table in that equation? What can we find? We can find N2. Now, is that really what the question's asking us for? It's asking how many additional moles of helium gas must be added. So we've got 0.22 moles in there now, and we have to add some. What's this going to tell us? N2 is going to tell us the total number of moles of gas at that new volume, right? So if we knew this number and we knew how much we started with, we could figure out how much needed to be added, right? It's just going to take one little extra step at the end. So here's our equation, V1 over N1 equals V2 over N2. And we are solving for N2. So again, we have an equation that has fractions in it, and so we need to cross multiply to get rid of the fractions. We end up with V1 N2 is equal to N1 V2. Just open it all the way. You're making the rest of us hungry. Yeah, just go quick. Just go quick. V1 N2 equals N1 V2, and now we rearrange for N2. See, the thing is, the YouTube people are wondering, what the heck are we doing with all the trains and the wrappers for the food? So there's V1, and we have to do the same thing on this other side, V1. This V1 over V1 is 1. It goes away. So N2 is equal to N1 V2 over V1. N1 is 0.22 moles. V2 is 6.4 liters. Divided by V1, 4.8 liters. And when we look at these units, the liters cancel out. 0.22 times 6.4 divided by 4.8. 0.29 moles. That's the total amount of helium gas at the new volume of 6.4 liters. We want to know how many additional moles of helium gas must be added. So it started out with 0.22, and we need to get to 0.29. So we're going to subtract what we started with, and we need to add 0.07 moles of helium. So that's a little twist in the problem. They're not all going to be exactly the same. Question?
How come the V's got larger going down and got larger going down? But they're supposed to be opposite.
No, volume and amount are proportional. If one gets bigger, the other gets bigger. Pressure and volume are inversely related. Yeah. Good observation, though. Any other questions? Yes?
And I say I do it something similar to that. I divide 0.64 by 4.8, then I multiply that by 0.22. So I end up with 0.29333.
Okay.
That's the way I do it.
Yeah, that's probably a ratio method. I'll just tell you about that real briefly. We're trying to find n, so we take the n that we're starting with, and we're going to make a ratio out of the volumes. And you ask yourself, well, is this going to result in n being larger or smaller? N has to be bigger, and so I'm going to make these into a ratio that will cause n to be bigger, and I'll multiply by 6.4 and divide by 4.8. That works really well for people with a certain kind of mind, okay? But other people just crash and burn. So if that works for you, you do it that way. It's awesome. Any other questions?